Hello everyone, I am Surendra, Master Teacher of Mathematics in Vedantu. In my weekly sessions on ISI and CMI preparation, I have been taking many topics, subtopics of various parts of mathematics. Also, I have taken 1 or 2 years of previous year papers from CMI and ISI. Today, I will extend that and I will be solving one paper of ISI which was conducted in 2018. First, I will be taking part A, in which 30 single correct questions were given. I will be analyzing on their difficulty level and how you could have approached them given the exam pressure. So let us start. So this is the first question, which says let x between 0 to 1 by 6 is a real number. When a certain biased dice is rolled, a particular face f occurs with probability 1 by 6 minus x, and its opposite face occur with probability 1 by 6 plus x. The other four faces occur with probabilities 1 by 6 each. Recall that opposite face sum to 7 in any dice. Assume that the probability of obtaining the sum 7 when two such dice are rolled is 13 by 96. Then we have to find the value of x. First of all, you should understand they are saying that any two opposite faces will have numbers such that their sum is 7. So 1 will have 6 opposite to it. Similarly 2, 5, 3, 4. Now, how to find probability of sum equal to 7? This is possible in 6 scenarios. Please listen what 6 scenarios I am talking about. We are actually rolling two such dice. Okay, so there are two possibilities. Either you get 1 on first and you get 6 on the second, or converse. We get 6 on the first and we get 1 on the second, and so on. Okay, here we are not given that which particular face f has probability 1 by 6 minus x and 1 by 6 plus x. So without loss of generality, we can assume that these are two faces which are having probabilities 1 by 6 minus x and 1 by 6 plus x, and all remaining faces are having probabilities 1 by 6, 1 by 6, and so on. So here the probability of getting 2 comma 5 or probability of getting 5 comma 2, and similarly probability of getting 3 comma 4 and probability of getting 4 comma 3 we will be calculating. This we are given to be 13 by 96, and on the right hand side, first dice getting 1 will be having probability 1 by 6 minus x, and after that on the second dice we get number 2 be 6 will have probability 1 by 6 plus x, and these will be multiplied by that multiplication rule. And also these events are independent, so we can directly multiply them. Now probability of getting 6 on first dice and 1 on the second dice will just be repetition of this thing. The difference will be that 1 by 6 plus x will come first and 1 by 6 minus x will come later. So I will just multiply it by 2. Similar to this, I can club these two probabilities together and they will be 1 by 6 into 1 by 6 into 2. And similarly 3 by 4 and 4 will also be 1 by 6 into 1 by 6 into 2. Now I can divide by 2 both sides and we will get 13 upon 192, and here it will be 1 by 36 minus x square plus 1 by 36 plus 1 by 36. So 1 by 36 is coming 3 times, so it becomes 1 by 12 minus x square. So this x square will be equal to 1 by 12 minus 13 upon 192. We can take 192 as LCM. So 12 ones are 12 and then 6 here minus 13. So this x square comes out to be 3 upon 192, which is 1 upon 64. So this x will be equal to 1 upon 8, and that is the answer for this question, that is A. So this question I think was not difficult at all. Under exam pressure you might do some error in this calculation, otherwise question is easy. You can call this as average type question from all angles, like calculation and thinking how to do it. So average question, I will say this for this question. Now coming to second question, which says an office has 8 officers including 2 who are twins. 2 teams, red, blue, of 4 officers each are to be formed randomly. What is the probability that twins would be together in the red team? Now there are multiple methods for doing this question. My first method is that this required probability would be, first of all, total number of ways, in which we will be first making 2 groups of 4 each. And because groups are of same size, so additional 2 factorial should be dividing it. But which group will be going to be called as red and which will be called as blue? So we will be multiplying by 2 factorial also. Now we want these 2 twins to be going to red team. So now I will be making 2 groups from 6 officers in which 2 twins are not counted. So 2 factorial, 4 factorial. 2 groups are of different size, so no additional 2 factorial division here. Now the group having 2 officers along with 2 twins will be going into red and 4 remaining will be going into blue. So that is all about this calculation. So if we do it, 2 factorial will be cancelled and this 4 factorial will also be cancelled. We will be having here 4 factorial into 6 factorial upon 8 factorial into 2 factorial. This 6 factorial will cancel 8 factorial, 8 into 7 times. This 2 factorial will cancel this 4 factorial, 3 into 4 times. So we get here answer to be, I think, 3 upon 14. So this is one method. Answer is D. Now coming to second method. What I am going to say, I will arrange 8 officers in a row randomly, 1 2 3 4 5 6 7 8, and I will call first 4 to be red team and next 4 to be blue team. Okay, so the probability will be, in denominator we should have 8 factorial, but in the numerator I have to make sure that these twins get place in first 4 places. So 4C2 to get which 2 places, and into 2 factorial to arrange these twins in 2 places, maybe let us say these 2 places, and then 6 factorial. You can check, this will also give us the same answer, 3 upon 14. I have one more method, I will just tell you briefly. Think of that how we can send these 2 twins. Without any condition, I think it will be 8 into 7. They can go at any place for first twin officer and 7 for the second twin officer. Okay, but if I have to keep them in first 4 places, then they will be having 4 into 3 ways. 4 ways for first officer and 3 ways for the second officer. This way also you can check, this gives us 3 upon 14 as the answer. So answer is D. Okay, coming to this 3, but before that I will call this question as easy. Okay, any one of the method you can apply, question is easy, but if you think calculation is also major part of it and you are not able to think this method 3 or method 2, then you can say slightly average side but not very difficult or difficult at all. Coming to question number 3, which says, suppose Roger has 4 identical green tennis balls and 5 identical red tennis balls. In how many ways Roger arranged these 9 balls in a line so that no 2 green balls are next to each other and no 3 red balls are together? First of all, I will make sure that no 2 green balls are together, ignoring this fact for a moment. So if I ignore this thing, so first step would be that we arrange 5 identical red balls, and that will be done in just one way. Then 4 identical green tennis balls to be arranged so that no 2 green balls are next to each other. For that we will be finding 4 gaps between these 6 gaps between these 5 red tennis balls. 1 2 3 4 5 6, 4 in between and 1 on the left, 1 on the right. So among these 6 gaps we have to choose 4, and there we will be putting 4 identical green tennis balls in just one way. So that is just 15 But here we have to make sure that 3 red balls are not together. And how can 3 red balls be together? Let us see if it is possible at all. If I put these 3 red balls together and I say there will be no green ball in between, is it possible? Let us see. So it looks like it is possible, because if we place our 4 green balls like this, one here, one here, one here and one here, it is possible. So we can actually make the group of 3 green balls in 3 different ways. You can check. This is also a possibility in which these 3 green balls in between are together, and these 3 green balls can be together on the right hand side also, this way. So 1, 2, 3, yeah, one more, and this is. These are 4 places for green tennis balls. So there will be 3 places, 3 ways in which these green balls will not be together, but 3 red balls will be together. So I have to subtract 3 from 15. So my answer will be 12 for this question, that is D. This question was, I will say, average, because this thing that no 3 red balls are together, this is little tricky. Otherwise question is fine. Coming to the next question, which says number of permutations sigma of 1, 2, 3, 4 such that sigma I minus I is less than 2. First of all, please understand what is the meaning of sigma I here. I have to permute 1, 2, 3, 4. Now, suppose 1, 2, 3, 4 were initially at these places, 1, 2, 3, 4. Now, my sigma 1 can go at any place, maybe here. Sigma 2, I can put maybe here. Sigma 3, I can put it here. Sigma 1, I can put it here. Sigma 4, I can put it here. So in that permutation of 1, 2, 3, 4, I is going into the sigma and it may occupy some different place. If there was no such condition, I think 4 factorial is the number of ways. But what they are saying, sigma I minus I should be less than 2. So this number written here and number originally was whatever it was, the difference should be less than 2. So I think this 4 cannot be placed at this 1 here, because difference here is 3. 1 can be placed at this 2, 2 can be placed at this 3, 3 can be placed at this 4, but this 4 cannot be placed at this 1. Now, how to do this question? I have 2 methods. Please listen carefully. My first method is, I will be putting at last place first, and at last place, because my difference can be either 1 or 0. They are saying less than 2, and sigma I will be integer, I is integer, so this will be either 0 or 1. So at this place 4, either I can put 3 or I can put 4. I hope that is clear. Now, if this is 3 here, then where will this 4 go? I think 4 can go only at this place, because if you put 4 at this place or this place, this difference will be either 2 or more than 2. So if 3 is here, 4 has to be here, then I have to permute 1 and 2 with this condition. I think we will be having 2 ways in this scenario, because 1 can be placed anywhere, 2 can be placed anywhere, my difference will be less than 2. So here 2 ways. Now what about this scenario? If 4 is here, you can see this problem seems like my question is only for 3 numbers and I have to place them at 3 places with the same condition. Okay, so here is at this place either 2 can be placed or 3 can be placed. So we will make 2 cases here, 1, 2, 3, 4, 1, 2, 3, 4. In this case 4, 4 here. I am putting 4 in both the cases, but here I will be putting 2, here I will be putting 3. If you put 2 here and this is 3, then 3 has to be put here. Otherwise, if you put 3 here, it will be having difference of 2. So I think in this case, 1 has to be kept here. So we have only one way in this scenario. If 4 is here, 3 is at third place, I think once again 1 and 2 are having two possibilities. So 2 for this case here. So 2 here, 1 here, 2 here. So total will be 5. So answer will be D. Now my method 2 is actually a general method. Suppose instead of 1, 2, 3, 4, I was having n such numbers. In that case, suppose total number of such permutation with this condition is an. Okay, now what will happen? This an will be actually equal to two things. Either in the last nth place, you place n here. Then what we will be doing? We will be placing n minus 1 numbers in n minus 1 places with this condition. Or we will be putting 1, 2, 3 and so on. I will be putting n minus 1 here. Then n has to be put here, n minus 1th place. Then these are n minus 2 numbers which are to be placed in first n minus 2 places. So this an will be an minus 1 plus an minus 2. So this is one recurrence relation. If we obtain, we can find for n equal to 5 also, 6 also, that will not be difficult at all. And here I think method 1 is decent enough, not required this method 2 for this particular question, but still if you want to use, you can see that A4 will be equal to A3 plus A2. A3 can be written as A2 plus A1. So we will be having 2 times A2 plus A1. A1 is nothing but 1 only, because if you are having only just one number with this condition, only one case, and A2 will be 2. So 2 into 2 plus 1. You can check that our calculation here was also on the similar lines. So answer is 5 for this question. Okay. Now coming to next question, that is question number 5. Here we are given that fx is a degree 4 polynomial with real coefficient, and z is the number of zeros of f, and e is the number of local extrema, that is local maxima or local minima of f. Which of the following is a possibility for z comma e? So first, if I notice at this where z is 4, that is fx is having 4 zeros. 4 zeros means it should be such that it will be intersecting this line at 3 times, at 4 times. This x-axis 4 times. Now, whatever this fx is, its derivative will have 1 degree less than fx. So it will be cubic. So it can have at most 3 real roots. So having 4 maxima or minima is just not possible. Okay. Now with the same logic, I'll say because f dash x is cubic, so it should have at least 1 real root. So at least 1 real root. So if it is having 1 real root, so d is also not possible. Fx may have 0 roots, but f dash x will have at least 1 real root, and in that case it will have at least one point of maxima or minima. Okay, you can see if it's a 4 degree polynomial, if it is having 0 roots, it will be like this. On both ends, x going to minus infinity or x going to plus infinity, because it's a even degree polynomial, both ends it will be going towards infinity. So in between there has to be 1 point of maxima or minima depending upon what is my leading coefficient. So this d is not a possibility. Now let us think about b. If it is having 3 zeros, 3 zeros are possible only if the situation is like this. 2 distinct roots, 2 distinct zeros, z1, z2, and third zero is such that it is repeated twice. In this scenario, you can check it will be having 1, 2 and 3 point of maxima or minima. So this seems correct. Which of the following is a possibility? Now, B being correct, I think our job is done, but still if you want to see whether 2, 2 is a possibility or not, so you should understand when will be 2 zeros. There is one possibility when there are 2 zeros, 2 real roots and 2 imaginary roots for this 4 degree polynomial. In this case, there will be just 1 real root between the 2 zeros z1 and z2, and this can be concluded by This can be concluded by Rolle's theorem also, that between two roots there will be exactly one real root. So just one, not two. If you are having two real and two imaginary, so this is not a possibility. Now what can be the other possibility? You can have two roots, two zeros like this also. Both are repeated twice, z1, z2. In this case, 2, 3 will be the possibility, because there will be two root zeros but 3 number of maxima or minima. So that is also not possible here. And what can be the other possibility? Let us see if, yeah, there is one more possibility like this. Please see. This 1, 0 is z1 and other 0 z2 is having repetition thrice. Just one example I will take for this scenario, that fx is equal to x minus 1, x minus 2 power 3. Okay, so there are two zeros for fx, but if you differentiate it, f dash x, if you do, you can check this x minus 2 whole square will be common, because if we differentiate, if x minus 2 is factor thrice, its derivative will have this factor to be twice. Okay, and then there will be some linear factor remaining. Okay, so for f dash x you can check, this will give us 1 point of maxima or minima, but this is not a point of maxima or minima, because here there is no change of sign for f dash x. Power is 2. So with the 2, again it will be 1 only. I hope you are getting it. With the 2 we got 1 here also. With the 2 we got 1 here also. With 2 we got 3. But with 2 I am not getting whether we can find 2 in any of these scenarios. Maybe I'm missing something. I don't think so. Just let me check. Let me take another slide where I'll do the remaining calculation. Yeah. So let me see if that's a possibility or not, that it goes like this, and goes like this. So this is a point of inflection, but if it's a point of inflection, this will not be a point of maxima or minima. So there will be just one point of maxima, minima here. So 2, 2 doesn't seems to be possibility here as well as. Let me check if one more possibility can be explored. No. 3 point of maxima minima. I think B is the answer. Let me know if you think there, because I heard from some of the students that 2, 2 could have been the possibility. That is why I am emphasizing that 2, 2 is a possibility or not. If I am missing something, please let me know. I will discuss it in the next session. Okay, so this question I will say was easy, because A and D was very much obvious that they cannot be the answer, and B could have been thought of in 1 or 2 iterations, and once we got the answer, you will not be thinking about C that much. So B is the answer, and I will say question is little average side, you can say, but not difficult side. Okay, now coming to next question number 6. It says number is called a palindrome if it reads same backward or forward. For example, 1, 1, 2, 2, 1, 1 is a palindrome. How many 6-digit palindromes are divisible by 495? First of all, what is 495? 5 is clearly factor of it. 5 nines are 45, 5 nines are 45. So this is actually 5 into 9 into 11. So in order this to be divisible by 5, and it's a palindrome, so 1, 2, 3, 4, 5, 6. Whatever will be here, we have to put it here also. So in order this number to be divisible by 5, we have to put 5 only here, because if you put 0 here, then first place will also have 0, and then it will not be a valid 6-digit number. So at first place and last place we have to keep 5 only. Now at this place, if I put a number n, suppose, then this place will also have n. If I put m here, then this will also have m, so that it becomes a palindrome. Now, I have to make sure that it's a multiple of 11 or divisible by 11. I think that is very much easy, because divisibility test of 11 is just that you add the numbers at alternate places, 5 plus m plus n, and do the difference with the remaining n plus m plus 5, and this comes out to be 0, so it has to be multiple of 11. Now, to make this multiple of 9, what we need to do, we have to make sure the sum of all the digits. So 10 plus 2n plus 2m. This has to be 9k, multiple of 9. So this 2 common, n plus m, has to be 9k minus 10. Now what are the possibilities? Please understand, n and m are single digit integers. They can be 0, 0, but they cannot be negative. So if I take k to be 1, I think we get minus 1, so that is straight away rejected. If I take k is equal to 2, this will be 8 here, which seems to be a possibility. If I take k is equal to 3, so 27 minus 10, 17, also not a possibility, because this is 2 into n plus m. N plus m is an integer, multiplied with 2 will give you even number, so it cannot be 17. Similar to this, if I put k is equal to 4, this will be 36 minus 10, 26 seems to be a possibility. K is equal to 5 will not be a possibility. K is equal to 6 if I take, so 6 into 9, 54 minus 10, it will be 44. But please understand, n and m being one digit numbers, so their maximum sum can be 18, and 18 into 2 can be maximum 36. So this 44 is also not a possibility. So what we have got m plus n to be either 4 after division by 2, or it can be 13 if it is 26. Now m and n can be 0 also. For this 4, I think we can have values of m to be 0, then n4, then 1, then this will be 3, 2, then this will be 2, this 3, then this will be 1, this 4, then this will be 0. So in this scenario, we are having 5 cases. Whereas in case of 13, my least value of m can be 4, because n can be at max 9. Then 5, then it will be 8, and so on. In the end, this can be 9, this will be 4. So if you count from 4 to 9, I think we are having 6 cases here. 4 to 9, this is 6, yeah. So either 4 or 13, so we are having 5 plus 6, total 11 number of cases for this question. So answer will be B for this question. I think this question was little difficult on side, I will say, because you have to make sure that all divisibility tests are taken care of, and then you have made sufficient cases after rejecting whatever is not required, and then counting all these scenarios correctly. So this question, I will say, little difficult on side. Okay, coming to the question number 7. We are given A is a square matrix of real numbers such that A power 4 is A. Then which of the following is true for every such A? So using that property, the determinant of A power 4 is determinant of A whole power 4, I can write this as like this. Now doing the factors, determinant of A and determinant of A power 3 minus 1 is equal to 0. Determinant of A is just a real number, so this will be either 0 or determinant of A cube will be 1, which gives us determinant of A to be 1 only, because this is determinant of matrix of real numbers. So here every such A cannot have determinant to be equal to minus 1, so this seems correct. Determinant will be either 0 or 1, it cannot be minus 1. Now, although my question is done, but let us see B, C, D are correct, or we can directly say they will be wrong. A must be invertible. Must be invertible means determinant value should be 0. But as we said, determinant value can be 0 also. In fact, if you take one example, A as a null matrix where all entries are 0, 0, 0, 0, then it cannot be invertible and still this relation is satisfied. So this B is wrong. Similarly, A cannot be invertible, saying cannot be invertible means its determinant has to be 0. But I think that is also wrong, because if I take A as identity matrix, then also this relation is valid. But A equal to I will be invertible, so C option is also wrong. Now D option, again, if I put A equal to null matrix or I, you can see this relation is not true. So saying for every such I, this relation being valid is wrong. So only correct answer is A. Actually, how they have obtained this, that if you write this A power 4 minus A and then take A as common, A cube minus I, and writing I as I cube, and then write factors like this, A minus I, another factor as A square plus I square plus A into I. Okay, and this is equal to null matrix. So they are saying maybe because of that this will be equal to null matrix. But you know, in matrix, AB is equal to null matrix doesn't mean that one of them should be equal to null matrix. So here this equal to null matrix is not true for all A. In fact, I have shown you that if you take A as null or A as identity matrix, then also it is not true. Okay, so this question I will say easy, because you are getting kind of a jackpot by just finding the determinant value of A, and you get A as the answer. You can ignore B, C, D then. Coming to next question, that is 8. Here we are given that consider the real valued function h from 0, 1, 2, 3 up to 100 to R such that h0 is 5, h100 is 20. And satisfying h1 is equal to 1 by 2 h I plus 1 is plus h I minus 1. I can write this relation as 2 times h I is equal to h I plus 1 plus h I minus 1. So we can say h I minus 1 comma h I plus 1, they are in AP. And that will be valid for all I from 1 to 99. That means H0, H1, H2 is in AP. Okay, and likewise H1, H2 and H3 is also in AP. Now what I am trying to tell you, you may think of that these two AP may have different common difference, because this is one AP, this is other AP, but the common difference of this first one is H2 minus H1, and same is common difference for this HP also. So combining these two things together, I can say that starting with H0, H1, H2, H3, they are same AP. In fact, this will go up to H99 and H100 also. So they are in AP. So it is actually like H0, we know it is 5 and H100 is 20 as given in the question. So this will be having 101 terms, 101 terms in this AP, and 101th term is 20. So I can use this as 101th term 20 equal to A, that is 5 plus n minus 1 into D, and this will give us D to be equal to 15 upon 100, that is 0.15. And we are supposed to find H1. H1 is just the second term of this AP, so H1 is actually equal to 5 plus D, that is 5.15. So answer will be A. I think this question is easy. If you can figure out that all these H0, H1, H2 are going to form AP, then this question is just easy, and this thing is not very difficult to observe. Okay, coming to next question, that is 9th question. Here we are given that an upright path is a sequence of points A0, A1, A2, where A0 is X0, Y0 ordered pair, A1 is X1, Y1, A2 is X2, Y2 and so on, such that AI plus 1 minus AI is either 1, 0 or 0, 1. What they are trying to say, this is one very standard thing, we do this in our PNC. We have to go along upright path. Upright path means either up or right. I will call, if you go up, I will call this as a vertical movement. If you take horizontal path, if you go right, I will call this as a horizontal movement. So we are supposed to take either vertical step or horizontal step. Then only if you compare two consecutive terms, the difference will be either in X alone or in Y alone. Okay, so it is just that standard thing that we used to do, that if you start with 0, 0 and you are going at m, n, then number of ways of going from 0, 0 to m, n in up or right path is just m plus n factorial divided by m factorial n factorial. How does this come? Actually, we are supposed to take m horizontal steps and we are supposed to take n vertical steps. Now we have to arrange these h, v, h, v and so on in a row in which all h are identical or v are identical. So by that theory of arrangement of identical objects, we can write this as m plus n factorial upon m factorial n factorial. Now our question is that we have to go from 0, 0 to 100, 100, but via this 1, 2. So this is 0, 0. So 1, 2 means it would be here 1, 2. So suppose this is A point, this is B point and this is C point. So I have to go from A to B first, and that will be done in 3 factorial upon 1 factorial 2 factorial. Same formula which I told you here. Now B to C also I have to move. So that in that case I have to take 99 horizontal steps and 98 vertical steps. So total number of steps are 197. So 197 factorial upon 99 factorial, 98 factorial. So here this becomes 3 and this can be written as 197 C99 or 98 also you can write. But here in this option we are given 197 C99, so I will like to write like this only. So answer for this is A. Other options seems wrong definitely. Here we are given 2, here we are given 3, but this is not same as 197 C99. This question I will say as easy once you recognize what this language is, because this is something I have seen every student is studying in their PNC chapter. Okay, now coming to the next question, that is question number 10. We are given fx is equal to 1 by 2x into sin x minus 1 minus cos x. We have to find smallest positive integer k such that this is not equal to 0. I think best method to do this question will be using expansion. To find this limit, I will be writing the expansions of sine and cos, and this is one very important expansion, we should remember it, and if you have any difficulty, derive it using Euler's formula e power iota x, which is cos x plus iota sin x. So by expanding e power iota x, by comparing real part and imaginary part, we can write this very easily. Now sin x is x minus x cube upon 3 factorial and so on, minus 1 minus this cos x is having 1 minus x square upon 2 factorial plus x power 4 upon 4 factorial minus and so on upon x raised to the power k. Now this 1 gets cancelled. In fact, this x square by 2 also gets cancelled. You can check. This is 1, 2, 3 minus sign. So this will be with minus sign here, and we will be having this to be limit x approaches to 0 minus x power 4 upon 24 minus 1, 2, 2 minus sign. So plus here x power 4 upon 24. Yes, I think I made one mistake here. This is not 324. This is 3 factorial 6 into 2, 12 here. Yeah, upon x power k. Now there will be higher power of x also, but we will ignore them because x is approaching to 0. When x approaches to 0, the smallest power of x matters. All higher power doesn't matter because they will be very, very small as compared to this x. Now, what can be the maximum value of k? I think this maximum value of k can be 4, and we will still be getting non-zero limit. If you take k equal to 5, okay, if you take k equal to 5, then also you can check the limit will become infinity or minus infinity, you can say plus infinity, or someone can say doesn't exist. Okay, but for k is equal to 3, if you take, your power will be lesser in the denominator, higher in the numerator after cancellation of x cube, or lesser power if k is 2 or 1, then this limit will become 0. So to get this limit to be non-zero, the minimum value of k, smallest positive integer k that we can have is 4. For k to be higher values 5 or 6, you will be getting some power of x left in the denominator, and putting x is equal to 0 or approaching to 0, the limit will become infinite. You may call that as a limit does not exist also. But in that sense, what they are asking, limit not equal to 0, this k will be 4, 5 and so on. For k being 3, 2, 1, it will be 0. For k, 4, 5 and so on, it will be non-zero. So smallest positive integer k has to be 4. Answer is B for this question. Easy question. This question you can do by L hospital rule also, but I think use of expansion is much more easier than anything else. Coming to this question, it says 9 students in a class gave a test for 50 marks. Let S1 less than S2 and so on less than S8, S9 denote their ordered scores. Given that S1 is 20 and sum of all the scores is 250. Small m is the smallest value of S5 that can take, and capital M is the largest value that S5 can take. Then pair m comma m is given by. Okay. Now because S1 is 20, S5 cannot take value less than 20. And we are given two such options also where small m is 20. So we should first inquire whether S5 can be 20 or not. Now if S5 is 20, just with assumption with these options also, and it is a possibility because S1, S2, S3 all can be equal also. And given that S1 is 20, so least value will be 20 only. So to inquire that if S5 is 20, I think S4, S3, S2, S1, they all will be equal to 20, 20 each. Now, if they all are 20, the sum of first 5 scores will become 100. S5 till S1 it will become 100, and then we are having S6, S7, S8, S9, and this sum is actually equal to 250. Now, this 100, if I cancel it here, we will get this to be 150. Now, please listen carefully. Let us check whether with this S5 to be 20, this sum is 150 possible or not. I will say it in other way. What is the minimum possible sum of these 4 scores? I think S6, S7, S8, S9 can also be 20, 20, 20 because this is the condition we are given here. So if all of them are 20, 20, these sum of 4 would be 80. But they can have at max the value of 50 also. In that case, this will go to 200 also. So S6, S7, S8, S9 all getting 50, 50, 50. This score will become 200. So this 150 is definitely a possibility. In fact, 150 will be possibility in many ways. You can take S6 as 20, but S7, S8, S9 as higher values. You can take even S6 to be higher values, S7 even higher, S6 even higher, and S9 even higher. Still you can get 150. You can make many such example on your own. So what I'm saying that getting S5 equal to 20 is a possibility, and that is the minimum value which we can have. Now to get maximum, how we can get? To get maximum, what I'll do, I will say that let us have S1, S2, S3, S4 as least as possible, so that my remaining sum will be utilized in S5, S6, S7, S8, S9, and I will try to make S5 to be as large as possible. So if I keep all these 4 to be 20, 20, 20, their sum will become 80, and then S5 and so on till S9 to become 250, and I keep this 80 this way, I will have this to be 170. Now, how can I have S5 to be maximum? I think to have S5 to be maximum, and with this condition, we should keep all S5, S6, S7, S8, S9 to be equal. If I keep S9 to be higher, then obviously in order this sum to be 170, that's a fixed value, I have to keep S5 little lesser than if they all were equal. So this capital M I can obtain, capital M can be obtained when all S5 till S9 are equal. In this case, these are I think 5 to 9, I think 5. So 5M will become equal to 170. So M will be equal to 34. So the answer here is 20, 34, that is B. Little tricky question. During exam, I can understand thinking of all these things and having no doubt on yourself that I have done it correctly can be little difficult, but still if you were having decent enough time to solve this question was not difficult. You can call this question as average. Okay, coming to the next question, question number 12. We are given 10 red balls, 10 white balls to be arranged in a straight line such that 10 each are on either side of a central mark. Okay, so there is one line here and this is central mark, and we have to keep 10 on each side. Number of such symmetrical arrangement about the central mark is okay. So if I have to keep symmetrical about the central mark, I think the same number of red balls should be on both sides. So if 10 are the total red balls, so 5 will be this way, 5 will be this way. Same goes with 5 white balls, 10 white balls also, 5 this way and 5 this way. Now you have a freedom to make arrangement either on left side or on the right side. Suppose you make some arrangement on the left hand side, and that will be done in 10 factorial upon 5 identical red balls and 5 identical white balls. We are given 10 red balls and 10 white balls can be arranged in a straight line such that 10 each are on the either side of the central mark. Okay, they have not given these balls are identical. Okay, if they are not identical, then this question will become little tricky. Let me first solve it for these balls to be identical. So first you have made the arrangement on the left hand side. Right hand side arrangement will be automatically done because we have to make this arrangement symmetrical. So multiplied by 1, my answer will be A. Now, dear all, if balls are not identical, okay, at least 5 red balls should be similar to 5 red balls, then only you can make them symmetrical arrangement. You can make a symmetrical arrangement about central mark. If all are different, then I don't think this symmetrical arrangement will be possible. So although they have not given that all are identical or not, but I will go with that all are identical, all red are identical, and all white are identical. Otherwise there will be just assumptions that how many are identical, how many are not. So better to go with A. So this question seems to be easy if you understand what is the meaning of symmetrical arrangement. So just a formula of arrangement of alike objects. Now coming to question number 13, we are given z equal to x plus iota y is a complex number such that mod of z minus iota upon mod of z plus iota is less than 1. Okay, then we must have, I can write this as mod of z minus iota upon mod z plus iota less than 1, and then we can write this as z minus iota to be less than mod of z plus iota. Now if you understand geometrical meaning of mod, then this question is just 1 or 5 seconds, I will say 5 seconds away. Please see, if I put iota here minus iota here, okay, this z minus iota mod is actually distance of z from this iota, whereas mod z plus iota is the distance of z from this minus iota, and we want this distance to be less, this distance to be more. Now when will mod z minus iota equal to mod z plus iota? I think this will be when where our z lies on the perpendicular bisector of line joining iota to minus iota. So this equality will hold on this line, which is x-axis. If I want this to be less, that means my z should be towards iota, then minus iota. So this z should be this place, this way. So this means my y has to be greater than 0. So answer will be C. If you are not okay with this method, you are not able to think this way, then I will say write z is equal to x plus iota y, x plus iota y. So this will become x plus y minus 1 mod, and equal to this will become x plus iota common y plus 1. Just use mod, open it, you will get same answer. But I will recommend you should understand these geometrical significance also. Okay, now coming to next question, that is 14. S is equal to x minus y such that x, y are real numbers with x square plus y square is equal to 1. Okay, so please understand x square plus y square is equal to 1 means circle of unit radius with center at origin. I can take any point on it with cos theta comma y, cos theta comma sin theta, and we have to find the value of cos theta minus sin theta. And they are saying what is the maximum number in this set S. So this is one very standard thing. The maximum value of this is just under root of a square plus b square, where a is coefficient of cos, b is coefficient of sine. So this will be root 2, and you can see that maximum will be when cos theta is 1 by root 2 and sin theta is minus 1 by root 2. So answer for this will be B. Okay, this thing can be done using Cauchy squares also. I will leave this for you to do, and also by some by thinking of some equation of a straight line like this: x minus y is equal to k. Suppose x minus y takes value equal to k, which becomes equation of line with slope equal to 1. So depending upon what value of k is, this line can be like this. Okay. Now we also want this xy lying on this x square plus y square is equal to 1. So I have to choose lines so that they have at least one point common with this circle. Okay, and to get k to be maximum, my line will be such that it has maximum distance from, it is tangent to the circle, so that this k is having maximum possible value. And you can check this maximum possible value will be when you drop perpendicular from 0, 0 on this tangent, and this will be k upon root 2, and radius of circle is 1. So this also gives you the value of k as root 2. That is the maximum value of s. If you go even further, your line will have slope 1, but it will not have any point common with this circle. So these kind of x minus y equal to k are no use to me, because I want only those xy which are lying on this circle. Okay, question was easy. I think just taking cos theta sin theta is giving us the answer. So I think this question is easy, I will say. Coming to next question, that is 15. Here we are given that in a factory 20 workers start working on a project of packing consignments. They need exactly 5 hours to pack one consignment. That means 20 worker, 5 hours work. That means total 100 hours of work is equal to or equivalent to one consignment. Okay. Now every hour 4 new workers join the existing workforce. It is mandatory to leave a worker after 10 hours. The number of consignments that would be packed in the initial 113 hours is okay. So first of all, my first hour, I am having 20 workers and 20 work hours also. In the second hour or in the beginning of second hour, you can say 4 more workers will join, and in the second hour only I'll talk about 24 work hour work will be done in the second hour. In the third hour 4 more will join. So in the third hour 28 work hour will be done, and then so on and so on. This will go on till 10th hour. In the 10th hour, if you follow this AP, because every time 4 workers are getting added, so I think here it will be 56. Let me check. Yeah, 56. But after 10, there is one very important thing. In the 11th hour, because those 20 workers which are working from the beginning, they have completed their work hours, so they have to be relieved. So in the 11th hour, these 20 workers will leave, but 4 more workers will join. So 56 minus 20 plus 4, that is 40 workers will be working in the 11th hour. So my 11th hour will give me output of 40 work hours. Then for the 12th hour, 4 more workers will join, so it will become 44. But those 4 workers which joined in the second hour or in the beginning of second hour, they have completed their 10 hours, so they have to leave. So now onwards you can check every time 4 new workers will be joining, but 4 oldest worker you can say will be leaving also at the same time. So this will keep happening till my 113th hour. So by first hour I am having 20 work hours, then 24 and so on. I have a GP till 56, and then 40 work hour work for every hour from 11 to 113, and this will be 113 minus 10, that is 103. What is the sum of this GP? I think A plus L is 76 into N. N is 10 by 2 plus this will be I think 5120. 4 3s are 12. Yeah, 4120, and here this is 5 times, and 5 into 76 will be 380 plus 4120, so this becomes 4500. And because 100 work hours is equal to 1 consignment, so this 4500 hour will be actually equal to 45 consignments. So number of consignments that would be packed in initial this is C. C is the answer. Okay. Now coming to the next question, that is 16. We are given ABCD is a rectangle with its shorter side A, greater than 0. So let me make one rectangle like this. Shorter side is A, so this is also A, and perimeter is 2S, so the longer side will be S minus A, S minus A. Now let PQRS be any rectangle such that vertices A, B, C and D respectively lie on the lines PQ, QR, RS and SP. Okay, so this kind of rectangle we are supposed to make. So this is A, B, C, D. P should be here so that A lies on PQ, B lies on QR, C lies on RS and D lies on SP. Now we have to find the maximum area of such rectangle. So let us take this angle to be theta, because that's a variable. I could have taken this any value of theta here by tilting PQ with respect to AB. This angle is 90. This will be 90 minus theta. So this will also be theta. Same way if I do, this will be 90 minus theta, this will be theta. Now to find the area of this rectangle PQRS, I have to find side PQ, which will be PA plus AQ. And this PA is actually A sine theta. A sine theta. Because this angle at P is 90. So in this right angle triangle, using sine theta is equal to AP upon A. AP is A sine theta. And similar to this, AQ will be S minus A cos theta. So this is my one side. Similar to this, QR, if we have to find QR, this will become S minus A sine theta, S minus A sine theta plus A cos theta. A cos theta. This is 90, this is 90. Now, what will be the area of this rectangle? We have to just multiply these two things. So if I multiply these two, we will get S minus A square plus A square common into sine theta cos theta. Whereas other two terms, when this S minus A multiplied with this A, we will get sine square theta, and also when S minus A is multiplied with this A, then also we get cos square theta. So sine square theta plus cos square theta can be written like this, which is just 1. So this area is actually equal to, if I open this bracket, S square plus 2A square minus 2AS, and I can write this sine theta cos theta as sine 2 theta upon 2 plus here it will be SA minus A square. Now to find area maximum, I think this sine 2 theta should be equal to 1, because that is the maximum value of sine. So I will put this as 1. So dividing by 2, we will get S square by 2 plus A square minus AS plus SA minus A square. This A square gets cancelled, this AS gets cancelled. So the maximum area will be S square by 2. So very interesting to notice that this maximum area does not depend upon what is smaller side or what is bigger side. It just depends upon the perimeter S. So answer for this will be C. This question again not very difficult. If you can make such diagram, it is easy to solve. But again, it will take, this question will take at least 2 to 3 minutes or maybe 4 minutes to solve from beginning till end. Coming to next question, that is 17, it says number of pairs of integers x, y satisfying the equation is. Now please see this right hand side, which is 5 raised to the power 2018 plus 1, has to be even number, even integer. But also because 5 raised to the power 2018 can be written as 5 raised to the power 1009 whole square plus 1. So this is perfect square of an integer of an odd number. And this you should know, it is always 8n plus 1 types. 8n plus 1 types. Square of any odd number is always 8n plus 1 types. So that will be 8n plus 2 types. Though it is an even integer, but it is multiple of 2, but not multiple of 4. Okay. Now, right hand side is even. So that means x and y both odd, not possible. Why I am saying so? Because if x is odd, y is odd, x plus y plus 1 is also odd, and their product cannot be even. Okay, so either x and y both should be even. So x and y both even. Then also there is a problem, because even into even will give you multiple of 4. But my right hand side is only multiple of 2, not multiple of 4. Not possible. That means x even, y odd, or otherwise. In that case, if x is even, y is odd, I think x plus y plus 1 will also become even. So once again same thing, that in this scenario also there will be 2 brackets that will be even. So product will be multiple of 4, whereas right hand side is multiple of 2. So this is also not possible. So the answer here will be 0. No pair xy is possible for which this will become equal to this thing. Okay, in number theory we find many questions which we conclude in the end that it is not possible. Okay, so whenever you think that nothing is working out, then you should give one thought to this idea also. Maybe there is no possibility. So think of some contradiction, and if you get some valid argument, you can say answer is 0. Okay. This question I will say, if you are good at number system, not difficult, not even average I will say, but if you are not very good at number system, then it is average or even difficult also. Now coming to next question, that is 18, very tricky question. It says Pn be the number of digits when 8 power n is written in the base 6. So first I'll have to tell you what is base 6, how to write it. Let Qn be the number of digits when 6 power n is written in the base 4. For example, 8 square in the base 6 is 144. Please listen carefully. Why we are saying 144 in the base 6 is equal to 8 square? Just like decimal system, if 144 is at base 6, it should be, its meaning should be that 1 which is at hundredths place, it will not be multiplied with 10 square, it will be rather multiplied with 6 square. Similarly, this first 4 here will be multiplied with 6 power 1, and then 4 will be multiplied with 6 power 0, and you can check, this becomes 36 plus 24 plus 4, and it comes out to be, I think, 64. So that is why this 144 is the base 6 representation of 8 square in decimal. 8 square in decimal is equal to 144 in base 6. Now the question is how to say what will be the number of digits of 8 power n when we are writing this in the base 6. Okay, now please listen carefully. As you can see that 144 was greater than 36, but it was less than 216. Actually, this is 6 power 2 and this is 6 power 3. Okay, so the number of digits in this 144 were 3. Or let me write this way, P of 144, P of 2, actually P of 2 is equal to 3. 2 is coming from 8 power n. So number of digit in 8 square is 3, and why it is 3, you can see that because 144 is between 6 square and 6 cube, so the largest integer, or I should say the biggest digit, or I should say digit with the highest numerical value will be here multiplied with 6 square, not with 6 cube or higher, because this number is bigger than 6 square but less than 6 power 3. So number of integers that will be, they will be 3 here. I hope that is clear. So what I can say, that whenever my 6 power n is bigger than 6 power m but lesser than 6 power m plus 1, then this P of n is going to be m plus 1. I hope that is clear. Because this 6 power n, when written in that base 6, okay, it will be having 6 power m multiplied with some number here, and then 6 power m minus 1 multiplied with some number here, and so on and so on. So total number of digits here would be m plus 1. Okay, now if you have understood this well, please understand here this m is actually equal to log of 8 power n to the base 6 JINT. I hope you understand this. M is integer. Okay, so this m is actually equal to greatest integer part of log of 8 power n base 6. What we are looking for? We are looking for that number m, which when raised to 6 will give me a number that is slightly lesser than 8 power n. So that is what log is doing for us. So here m will be equal to log of 8 power n base 6 JINT. JINT plus 1 actually. JINT plus, this is actually m, but if I have to find P of n, that will be log of 8 power n JINT to the base 6 plus 1. Okay, now similarly, if I have to find Qn is what? When 6 power n is written in the base 4. So this will be log of 6 power n base 4 JINT plus 1. Okay, now we have to find this limit. Let me use this space after this. We have to find this limit n approaches to infinity. So when this limit n approaches to infinity, this JINT can be written without this bracket also. I will tell you why. Let me take another slide for this. Okay, so far we have proved that this will be equal to limit n approaches to infinity, greatest integer of log of 8 power n base 6 plus 1, another bracket, greatest integer of log 6 power n base 4 plus 1 divided by n square. Now inside this log, I can write this as limit n approaches to infinity. N can be taken outside, log 8 base 6 JINT plus 1. Okay, and in another bracket, we can write this as JINT of n into log 6 base 4 plus 1. Now, because n is approaching to infinite, Okay, so this GINT, if I write like this, n log 8 base 6 minus fractional part of the same thing, and this lies between 0 to 1. Because this lies between 0 to 1, we can ignore this as compared to n into log 8 base 6, because n is approaching to infinity. So what I am saying, this limit will be same as n approaches to infinity, n log 8 base 6 plus 1. In fact, this 1 can also be ignored because this n is going to infinity. And here also I can write n log 6 base 4 plus 1 upon n square. The same thing can be proved using sandwich rule in limits, but here we can do it directly also if you have a good understanding of why we have ignored this fractional part, because it is having very small value as compared to n into log 8 base 6. Okay, so here I can write this as limit n approaches to infinity. If I multiply these two terms first, I will get log 8 base 6 into log 6 base 4 plus. If I multiply n term with this one or this n term with this one, here we will be getting log 8 base 6 plus log 6 base 4 upon n and plus 1 upon n square. Because n is approaching to infinity and these numbers are finite, so these terms will be 0, 0. So we are only left with these two terms, which can be written directly now, log 8 upon log 6 into log 6 upon log 4. So log 6 gets cancelled, and log 8, if I write at the base 2, will be 3 here and 2 here. So answer for this would be 3 by 2. So answer is C. I will definitely call this question as a difficult one, because thinking of that this Pn will come from log is not that spontaneous. You have to write a few examples before this will strike you that it is GINT of log 8 power n base 6 plus 1, unless you have done it already before or you know such formula already before. Okay, so coming to next question, that is 19. We are given that for a real number alpha, S alpha denotes set of those real numbers beta such that alpha into sine beta is equal to beta into sine alpha. Then which of the following statements is true? Okay, so this is saying for any alpha, S alpha is infinite set. For any alpha, S alpha is infinite set. Okay, so this relation can also be written like this: sine alpha upon alpha is equal to sine beta upon beta. Okay, now if for any alpha, let me first draw a graph for sine x upon x. Okay, sine x upon x, as x approaches to 0 is 1. This is when one very important, very famous limit. So we can write 0 here, we can mark 1 here, barring at 0, because at 0 it will be not defined. But after this, if we draw the diagram, sin x upon x will be going like this and this and this and so on. You can think of that sin x is taking sinusoidal wave, but because as x increases, denominator becomes more, so the net ratio will be lesser in magnitude. So every time you draw like this, every time you increase x, the magnitude will decrease. In fact, this sin x upon x will be even function. So on other side also you can draw like this. Now let us read first option. For any alpha, S alpha is the infinite set. Is it so? Let us see. Suppose I choose some alpha here. Okay, so how many beta we can claim to have so that sine alpha upon alpha is equal to sine beta upon beta? I think if this is alpha, then different value of beta other than alpha will be just 1 here, because all other maximas lying below it. So saying that for any alpha it will be infinite set is wrong. As alpha is a finite set if and only if alpha is not an integer multiple of pi. Okay, let us see. Let us first see if alpha is integer multiple of pi. Suppose alpha is n pi. Then I think this will become 0. Okay, so if this becomes 0, we will be getting alpha sine beta is equal to 0. So beta for any integer multiple of alpha, in any integer multiple of pi, I think beta can be any value that is integer multiple of pi. So here beta can take infinite values. Okay, so but question was as alpha is finite set if and only if alpha is not integer multiple of pi. So what I have proved that if alpha is integer multiple of pi, then S alpha will be infinite set. That is what I have proved. S alpha is denote the set of all those values of beta for which this relation holds true. So here S alpha is a finite set. I think it seems correct. Let me tell you why. First of all, I have proved that if alpha is integer multiple of alpha, then S alpha is infinite. Now, if alpha is not integer multiple of pi, that means this will not be 0 and this will be other than all these points. These points are corresponding to pi, 2 pi, 3 pi and so on. So whatever value of alpha you choose, okay, and because this is decreasing sequence, so after certain interval, whatever alpha you choose, maybe here or here, your value of sine alpha upon alpha will be bigger than any value that you may obtain for other cycle of this graph. So only finite set F's alpha if alpha is not multiple of pi. So that should be correct. Let me first check other options also. C says there are infinitely many numbers alpha for which S alpha is the set of all real numbers. There are infinitely many values of alpha for which S alpha is the set of all real numbers. Okay. If I take alpha to be 0, you can check in this relation beta can be any real number. But this seems to be true only for when alpha is equal to 0, not when alpha is multiple of pi, not when alpha is not multiple of pi. So there are infinitely many values of alpha is wrong for which S alpha is set of all real numbers. S alpha will be set of all real numbers only when alpha is equal to 0. I have proved it when alpha is other than 0 and it is integer multiple of pi, then beta will have infinite values but they will be all k times pi. So they are not all real number. So C is wrong. Now C alpha is always finite is also wrong because we have seen S alpha can be infinite set also. One when alpha is integer multiple of n pi and not 0, and also when equal to 0 because then this will become entire real number. So answer for this definitely is B. This question I will say is definitely tricky, and coming to the conclusion that which option is correct, question is having confusing language also. So I think during exam I will rate this question to be difficult. Coming to the next question, that is 20. We are given A is equal to 110 iota and A2018 is equal to ABCD. Then what will be A plus D equals? Okay. So see, I have two methods to do this question. Let us see how we can do it. One is that let us try to find what is A square. So if I find A square, it will be first row, first column, so 1 here. First row, second column, so 1 plus iota here. Then second row, first column, so I think 0 here. Second row, second column, so iota square, that is -1 here. Okay, now from this a square, if I try to find what will be my a power 4, please see. A power 4, if I do first row, first column, so I'll get 1 here. First row, second column. First row, second column, so we will be getting 1 plus iota, 1 multiplied with this, and this multiplied with this. I think we are getting this to be 0. Yes, and this multiplied with this, so 0 here. Second row, second column, I think 1 here. So I think this is something will work here because a power 4 is coming out to be I. So then I think it is done, because a power 2018, I can write this as a power 2016 into a square, which will be equal to I into a square, which is a square. So this is what my a power 2018 would be, and we will get a plus d to be equal to 1 minus 1, that is 0. So answer for this will be B. Now coming to question number 21, which says f R2R, G R2R be two functions, consider the following two statements. Statement 1 says limit x approaches to 0, fx exists. If this exists and this exists, then limit gx must exist. Dear all, this is one very common problem. Suppose fx approaches to 0, and approaches to 0 also comes under the category of existing the limit. So if fx approaches to 0, then whether gx exists or do not exist, this product limit may exist. So saying that if this exists, this also exists, then this will exist is wrong. So I will say this is false. Okay, now coming to second statement. F comma g are differentiable, fx less than gx for every real number x. Then f dash x is less than g dash x for all x. See, fx is less than gx. Okay, so let us make one function gx which is bigger than f. So this is my fx function, this is my gx function. Okay, now gx is relatively consistent. Consistent means it is not having that rate of increase or rate of decrease, almost like a constant function, whereas fx is having a steep increase, steep decrease. Okay, but all the values of fx are lying well below gx, so we are having this condition. Okay, but can we say that at every point f dash x will be less than gx? I think not at all. Gx is decreasing in this region, so g dash x will be negative. Fx is increasing, so f dash x will be positive. So saying f dash x will be less than gx is also wrong. So both statements seems false here. Let us see. Both are false. So answer is P. So this question is easy, I will say. If you have a good understanding over this limits and this differentiability thing, then this question is easier. Now coming to next question, which says number of solutions of the equation sine 7x plus sine 3x equal to 0. I think one simple question based on sine c plus sine d, 2 sine c plus d by 2, so sine 5x into cos c minus d by 2, so 4 by 2, so it will be 2 here. 4 minus 3, 7 minus 3, 4 by 2 is 2. Yeah, this will be 0. So either sine 5x will be 0, and sine 5x is equal to 0 means x will be, because x is from 0 to 2 pi, so 5x will be from 0 to 10 pi, both included, 0 to 10 pi. So corresponding to 0, let me first write 5x, so it will be 0, pi, 2 pi, and so on 10 pi. So my value of x will be 0, pi by 5, 2 pi by 5, and so on 2 pi. Or there is a possibility that cos 2x becomes equal to 0, which is true when 2x is equal to pi by 2, 3 pi by 2, and because 2x will be from 0 to 4 pi, so the values here can be 5 pi by 2 and 7 pi by 2 also. 5 pi by 2 and 7 pi by 2 also. So Corresponding to that, x will take 4 values from here, and 0 to 10 both included 11 values here. So total number of solutions will be 15 for this question. I think one very standard problem, one very easy problem. So this is definitely easy question. Unless and until you do some really very mess up things, this question should not go wrong. Coming to question number 23, it says a bag contains some candies. 2/5 of them are made of white chocolate, and remaining 3/5 of them are made of dark chocolate. Out of white chocolate candies, a bag contains some candies, 2/5 of them white and 3/5 of them dark chocolate. Okay, out of white chocolate, 1/3 are wrapped in red paper and rest are wrapped in blue paper. Out of dark chocolate, 2/3 are wrapped in red paper and rest are wrapped in blue paper. If a randomly selected candy from bag is found to be wrapped in red paper, what is the probability that it is made up of dark chocolate? So dear all, this question is one very simple problem on Bayes theorem. First of all, we will find the probability that candy is wrapped in red paper. So for that, first of all, it can be white chocolate also, whose probability is 2/5. And after it is white chocolate, 1/3 of them are red. So into 1/3. This is the probability of chocolate to be white, and this is the probability of being red given that it is white. Okay, plus similar to this, I can write 3/5 is the probability of this chocolate to be dark, into, if it is dark chocolate, 2/3 are red, 2/3 are wrapped in the red paper. So this is red given that it is dark. Now if you do the total of this, it will be 2/15 plus 6/15. So this becomes 8/15. Now what we are looking for, we are given that this candy was wrapped in red paper. Now we have to find the probability that it is made up of dark, given that it was red paper. So I think first thing, this thing is the contribution towards this probability that is coming from white chocolate, and this is a contribution that is coming from the dark chocolate. So this will be 6/15 whole divided by 8/15. So answer will be 3/4. B is the answer. Such questions are really difficult to read and to understand in the beginning because so much of English is written. But once you understand the question, there is nothing in such questions. Just practice more on such questions. Coming to the next question, that is 24. A party is attended by 20 people. In every subset of 4 people, there is at least one person who knows the other 3. We assume that if X knows Y, then Y knows X also. Suppose there are 3 people in the party who do not know each other, and let me call these 3 people who do not know each other as A, B, C. How many people in the party knows everyone? Very tricky question. Please see how this will be done. Suppose A, B, C and so on, there are 20 people, whatever number it goes up to, I am not sure. Let me call this as maybe S, okay, or maybe T, whatever, or let me check. After S, what is left? T, U, V, W, X, Y, Z. I think it will go till T. T is the 20th person. Now because they are saying any subset of 4 people, suppose if I make subset of 4 A, B, C, D, then subset of A, B, C, E, and because of this condition, there is at least one person who knows the other 3. So here this D will be knowing all the 3, because A, B, C are those 3 who do not know each other. So D will be knowing C, D will be knowing B, and D will be knowing A. With the same logic, E will be knowing C, E will be knowing B, E will also be knowing A. So that is one thing that we have proved, that out of D till T, all the 17 persons will be knowing ABC. But whether they will be knowing everyone or not, whether they will be knowing each other also or not, to know that thing, let us make one more subset in which AB will be there and then DE will be there. C I have not taken. Now because A doesn't know B, so A cannot be the person who knows all of them. Same goes with B also. Already D is knowing B, D is knowing A. E is also knowing B, E is also knowing A. So out of D or E, there will be one person who will be knowing all three of them. So D should be knowing E also. Or if it is E, then E should be knowing D also. But because if X knows Y, Y knows X also, so D and E both will be knowing each other. I hope that is clear. I'll repeat it. What I said, suppose A, B, D, D, E is the subset. Already A and B are not knowing each other, so A cannot be the person who knows all three. B can also not be the person who knows all three. So either it will be D who knows all three. Already D is knowing B and D is knowing A. So if D is the person who knows all three, D will be knowing E also. Now, because if D knows E, E has to know D also, as we are given that condition here. This means in such scenario, D and E has to know each other. Okay, now if I make all such subsets into where two peoples are A and B or A and C or B and C, then still out of 17 people, there are 17 C2 ways in which we can select two persons and we can make subsets in which two will be AB and two will be other two persons from D till T. But the logic we have proved that D and E knows each other, all these 17 persons has to know each other, isn't it? So how many people in the party know everyone? So answer will be B. Okay, it cannot be less than 17, it cannot be more than 17. More than 17 out of question, because then C will have to know everybody. But we are given that C does not know A and B. Okay, it cannot be 16, because in that case at least one person will not be knowing all the persons, and then we will be finding contradiction in such subsets with this condition that there is one person, at least one person, who knows the other three. So answer for this question is definitely B. Tricky question. I will rate this question also as a difficult one. Okay, now coming to next question, that is 25. We are given that sum of all natural numbers A such that this is a perfect square. I can write this as A minus 8 whole square plus 3, and this has to be perfect square. Now this means difference of two perfect squares is equal to 3. Now you can make Diophantine equation, but that is not needed. Please understand it. See, this B is perfect square of some natural number, isn't it? A minus 8 square is also perfect square of some natural number, or at least integer. Both are positive, and you know there are only two integers whose difference there are only two integers difference of whose squares is 3. One is 4, one is 1, isn't it? If you keep writing perfect squares 1, 4, 9, you can see the difference becomes more. So to become this difference to be 3, I think B square has to be 4 and A minus 8 whole square has to be 1. Then only there can be some such situation, otherwise there is no such possibility. So A minus 8 will be equal to plus or minus 1. So one of the value will be A is equal to by taking plus 1, and one of the value will be by taking minus 1. plus 8. And they are asking sum of all such values. So if you will add these two values, answer will be 16, because even this plus 1 minus 1 will cancel each other. 8 plus 8 will be 16, so answer will be C here. You can do it the other way also by making b plus a minus 8 as one bracket and 2b minus a plus 8 as another bracket, and then writing that as 1 into 3 or 3 into 1. I will leave this for you to do it yourself. One very standard thing, but I think this one was much faster. Okay, now coming to next question, that is 26. We are given that sides of a regular hexagon A, B, C, D, E, F are extended by doubling them. For example, this BA extends to BA dash and BA dash is equal to 2BA. So suppose this is A, then this AA dash will also be A. And this BB dash will also be A, to form a bigger regular hexagon A dash, B dash, C dash, D dash, E dash, F dash. Then we have to find the ratio. We have to find the ratio of areas of bigger to smaller hexagon. Okay. Now please see. In regular hexagon, this angle is 120 degree. So this angle will be 60 degree. So using cosine rule, it is very easy to find what will be my A dash, B dash. Let me call this as X here. So this will be A square plus 4A square minus X square upon 4A square in the denominator. 2 into A into 2A. And cos 60 is 1 by 2. So if I take this side, so 5A square minus X square is equal to 2A square. This gives us X square is equal to 3A square. So X is equal to A root 3. So X is equal to A root 3. Now that is all we need to do. If I compare both the regular hexagons, their corresponding sides are A and A root 3. And area, if we have to find the ratio of their area, bigger to smaller, it should be in the ratio of their squares. Area is always proportional to the side length. So it will be proportional to A root 3 square. It will be proportional to same proportional constant A square. So answer will be 3. Answer will be 3. That is all we need to do for this question. I think if you can understand this angle 60, I will rate this question to be easier. Not very easy, but not average also. I will call this as easy or slightly difficult than easy, you can say. Okay. Now coming to question number 27, which says between 12 noon and 1 p.m. there are two instants when hour hand and the minute hand of a clock are at right angle. The difference in minute between these two instants is okay. So this is 12, this is 1. Okay. So between 12 and 1, my hour hand is here and minute hand is somewhere here. So that the angle between them is 90 degree. There are two instants when hour hand and minute hand are at right angle. After some time, this will happen that it will come here and this minute hand will come here. And then also the angle between them will be 90 degrees. So they are asking the difference between minutes between these two instants. Okay. Now what I will suggest in this question, please understand every minute if I count, that minute hand rotates by every 1 minute. Please listen carefully. It is actually every 1 minute if I count, it is 60th part of 360. 360 upon 60, that is 6 degree. That is the rotation of minute hand. Whereas of hour hand, if you see, it will be in 1 minute. 1 minute it will be 30 upon 60. Because in 1 hour it rotates by 30 minutes. So in 1 minute it will rotate by 0.5 degree. I think I said something wrong. In 1 hour, our hand rotates by 30 degree. So in 1 minute, it will be rotating by 0.5 minute, and both are rotating in the same direction. So if I find relative rotation of minute hand over hour hand, I think it is 5.5 degree every minute. Okay. Now if I start in the beginning when it is 12 o'clock, both hands are overlapping. So angle between them is 0 degree. Okay. So when will be first time the angle will be 90 between them. I think if I call this time as T1 after 12 p.m. I think it should be that 90 degree upon 5.5 degree, because in 1 minute 5.5 degree rotation is there. So to get 90 degree rotation, relative rotation between them, we just have to divide by 5.5. Okay. Now what will be my T2? If I look at T2, I think this angle now from this side it is 90, but from this side it is 220. So it has to be 270 degree actually. So 270 degree upon 5.5 in minute. So difference of these two instant can be calculated directly. Take the difference 180 degree upon 5.5. We can write this as 360 upon 11. So 11 3s are 33 and 11 2s are 22. So 8 by 11. So 32 and 8 by 11 minute will be the answer for this question. Okay, I think this relative thing has made this question easier. Otherwise, you may take little more time, although it can be doable by that way also. But I think relative thing is a relative rotation concept is making this little bit better than any other method. Okay. Now coming to next question, that is 28. For which value of theta between 0 to pi by 2 does the quadratic polynomial have repeated root? Repeated root just d equal to 0. So that means 16 cos square theta minus 4 cot theta is equal to 0. B square minus 4ac. Okay. Because theta is not 0, theta is not pi by 2. Okay. First of all, we can remove this 4 from here, cos square theta minus, and I can write this as cos theta upon sin theta. So cos theta can be cancelled both sides. I can take sine also LCM. So 4 sin theta cos theta minus 1 upon sin theta is equal to 0. So this gives us sin 2 theta, 2 sin 2 theta is equal to 1. Sin 2 theta is equal to 1 by 2. So my 2 theta will be either pi by 6 or 5 pi by 6. Theta is between 0 to pi by 2, so 2 theta can take both the values. So for theta, it will be pi by 12 or 5 pi by 12. So pi by 12, 5 pi by 12, answer is D. Yeah, D. So I think this is very easy question. Again, once again, similar to what that sine 7x plus sine 3x. I think it is even more easier. There we had to solve 2 times. Here I think just once. Now coming to next question, which is let alpha, beta, gamma be complex numbers which are vertices of an equilateral triangle, then we must have. Dear all, there is one very standard result to remember, that if alpha, beta, gamma denote equilateral triangle, then alpha square plus beta square plus gamma square minus alpha beta minus beta gamma minus gamma alpha is equal to 0. If you multiply this by 2 and rearrange, it is very easy to see that it becomes alpha minus beta square plus beta minus gamma square plus gamma minus alpha square is equal to 0. So answer for this will be D. If you are not aware how this has come, you just have to do the rotation and you will be able to do it. This is alpha, this is beta, this is gamma. This angle is 60 degree here in anti-clockwise direction, pi by 3. This angle is also pi by 3 in anti-clockwise direction. Let me check anti-clockwise, anti-clockwise. So at this alpha, we may apply Coni's method or rotation method to obtain this result. But I will still say this one is one very standard thing, we should remember it. Now coming to the last question, which says assume that n copies of unit cubes are glued together side by side to form a rectangular solid block if the number of unit cubes that are completely invisible is 30, then minimum possible value of n is. So first of all, let us understand unit cubes is actually 1 into 1 into 1 side cubes, and by joining them we are forming a rectangular solid block. So if length, breadth and height of this rectangular solid block is A, B and C, so A into B into C will be equal to n. Now second thing, they are saying that number of unit cubes that are completely invisible is 30. So which will be the invisible units? Please understand, if I look from outside this rectangular solid block, from all 6 sides of this solid block, we will not be able to see those cubes which are one layer below from any of the side. So one layer below from above, one layer above from the lower side, one unit inside from both the sides, from left, right or front and back side. So what I am trying to say that if I remove one layer from all 6 sides, what will be remaining will be A minus 2, B minus 2 and C minus 2 dimension rectangular solid block, and this is something that will not be visible if it is complete. So inside that rectangular solid block, these are the number of unit cubes that are invisible, and this is given to us as 30. Now writing as ABC has to be integer and 30 is also an integer, so we can now find out what are possible values of ABC, which will give me minimum possible value of n. So first of all, let me take 30 as 2 into 3 into 5, which is actually product of 3 different prime numbers. So here A, B, C could be 4, 5, 7, which gives us n to be 20 into 7, that is 140. Now all prime numbers are taken in different factors, but if I take this 30 to be like combining 2 and 3 as 1, so 1 into 5 into 6. In this case my ABC could be 3, 7 and 8, and hence this n will become, and you can compare, this 7 was unaffected but 4 and 5 got shifted to 3 and 8. But if you look at their product, here it was 20, but here it is 24. That means the value of n has increased. 24 into 7 if you do, I think it will be 168. Yeah, 168. So you can see the value, minimum value is when we are taking 30 as 2 into 3 into 5, and this will be 140. It can be checked for other cases also. Every time value of n, if we take other than this scenario, it will be bigger than 140. So the minimum possible value of n here is 140. Okay, so this completes the solution of this paper of ISI 2018 part A. Next week I'll be coming with part B. So that is all for today. Thank you so much. Take care. Bye.